Assalamu alaikum dear students. In the series of learning C programming, we are discussing storage classes in C. In the previous video, we have discussed what is auto storage class. Every minute detail regarding the auto storage class with the help of the example have been discussed in the previous video thoroughly. And in today's video, we are going to discuss one more storage class in C, that is the register storage class in C. In this video, we will discuss how to declare a variable, how to declare a storage, register storage class. Or you can say how to associate a register storage class with the variable. And why do we use these register storage classes? And why we use register storage classes? Or we can say which variables we have to declare as register storage classes and why we have to declare, why we need these register storage classes. Every minute detail regarding this register storage class will be discussed in today's video with the help of the example. So our topic is the register storage class. Simply when we declare a variable, this is a declaration, simple declaration of the variable. Here only I have declared a variable x and the type of the data that is going to be stored in this variable is integer. This declaration tells us only these two things, that the name of the variable is x and the data that is going to be stored in that variable is of type integer. But we know that in addition to these two properties or three properties, the variable is also associated with other things as well. And those things are the default value, we can say location, scope, and lifetime. In addition to these things, in addition to these two properties, these things are also associated with the variables. And these things are going to be told us by their storage classes. And we know that first how to declare. By default, we know by default the storage class is auto. And now here only we are going to discuss a register storage class and how we have to declare the variable as a register storage class. Or I can say how we can associate a variable, a register storage class with the variable. Simply, here we are going to use a keyword register and then declaration of the variable, same as auto. That means in auto case, we write auto. Instead of auto keyword, here we have to write a register. In order to declare a variable as a register storage class, we have to use the keyword register. And then simply the name type of the variable, data that is going to be stored in that variable, and name of the variable. Now, what would be the effect? We know that these four things are going to be told by the storage classes. Now, what would be the effect of this register keyword on these four things? When we declare a variable as a register storage class, at that time, the default value is the garbage value, any garbage value. That means by default, the compiler will put it any the garbage value. Garbage, that means there may be some, either it may be some negative value, it may be a positive value, it may be some keyword, it can be anything, garbage. So, in case of register storage class, the default value is garbage. And third, scope. What would the scope of this keyword, this variable, then the storage class associated with it are register. At that time, the scope would be either a block scope or it can be a function scope or method, or you can say method scope. That means the scope of this variable is within a block or within the function in which that variable has been declared. If we declare this variable within a function, then the scope is only within that function. And if we declare this register variable within a block, then the scope of this variable is only within that block. And the lifetime of register storage class variable is also block within that block or function. That means the variable which has been declared as a register storage class is alive only within that block in which it has declared or within that function or a method. No global lifetime, no global declaration is, we can say, allowed in a register storage class. We cannot declare register storage class as a global. That means the global declaration is not possible in case of register storage class. Only a local scope. That means the scope is only local, not a global. Okay. Up to this point, we know that the auto storage class and register storage class. The similarity between the auto and the register storage class is that both auto as well as the register storage class have default value, garbage value. And second one, the scope in both cases, register as well as the auto, is block scope or a function scope, and lifetime is also block and a function scope. Now, what are the differences? Now the question lies, what are the differences between the static and the register? The difference lies only in case of location. We know in auto storage class, the variables are going to be stored either in the RAM. It is going to be stored in the RAM, or we can say in the main memory only. But in case of this register storage class, the variable is going to be stored in registers. This is the main difference. The main difference is between this auto and register storage class is that in case of auto storage class we use the keyword auto, and in case of register storage class we use the keyword register. Second difference is in case of location. In auto storage class the variable is stored in the RAM, or you can say in the main memory only. Whereas in case of register storage class the variables are stored in the registers, CPU registers. And now with the help of the example we will discuss this point, location. What would the effect? Why do we store the variables in the registers? That we will discuss it here with the help of the example. So first of all, I will write down here a simple program, and later with the help of that program we will discuss the effect of register storage class on the variables. And simply here man, for example, int man, here only int I and sum equal to 0 for I equal to 1, I less than 6, I plus plus. Sum equal to sum plus I, printf percentage d. Here I have written a small program which will print the sum of numbers from 1 to 6. That means it will print as 1 plus 2 plus 3 plus 4 plus 5. It will print as this, the sum of. That means 2, 3, 6, 10 and 15. The output of this program will be 15. Now, with the help of this program, we will discuss the working of this register. And simply, we know that whenever we write a program, the program is already in the hard disk. When we save the program, it is in the hard disk. For example, this program, which will print the sum of numbers from 1 to 6, it is in a hard disk. And when we want to execute it, we know that execution of any program takes place in the primary memory. That means in order to execute a program, we have to load it in the primary memory. So, here only, for example, this is our RAM, this is our program in hard disk. In order to execute it, we have to load it in the RAM. Here only, I have declared the two variables, I and sum. Both these two variables are static variables, we can say. And we know that these are, by default, they are auto. That means no keyword has been here associated with this int. And by default, the variable is auto. That means we know that auto variables are stored in the RAM. The location of the auto variables are RAM. So obviously, for example, here it is I and it is sum. For example, two variables I have declared, I and sum. And in sum, I have initialized 0. Now, after that, there is a for loop. Here only execution takes place. And the execution, actual execution, or we can say the processing of the program takes place in the CPU. Or we can say more here, this is our CPU processor. That component which is responsible for the processing is the processor, or we can say the CPU. And in the CPU there is ALU, arithmetic and logic unit. That arithmetic and logic unit is responsible for performing the execution, the processing of the instructions. And we know that in CPU there are some registers. For example, there are some instruction register, we can say IR, and there are some data registers, we can say DR. Instruction registers are for storing the instructions, for executing the instruction, and DR are for the data registers, for storing the data. For example, after execution this I equals 1, here I have declared I with 1, and after that I less than 6, here I equal to 1 and 6, I less than 6, then the control will reach here, sum equal to sum plus I. What is it? It's the instruction. It is an instruction. Sum equal to sum plus I. This instruction. And obviously, in order to execute this instruction, we have to load it into the IR. For example, here only, sum equal to sum plus I. I have to fetch this instruction into the CPU. In order to process this instruction, we have to fetch it into the here. But we know that sum equals sum I. What is the value of I? I is 1. And this instruction, we can say, this processing takes place on the data. The data is stored in the sum variable and in the I variable. That two are located in the RAM. In order to perform any operation here, we have to fetch these instructions. We have to load these data into the data register. So, we have to load I here first and sum also here, 0. Both I equal to 1 and sum equal to 0. We have to load also these things into the CPU. Now, here only, it will perform this instruction, sum equals sum plus I. What is sum? 0 plus I. 0 plus I equal to 1. 0 plus I. Because we know at that time, in sum there is 0 and in I there is 1. Here, sum contains 0, I contains 1. Equal to sum. Then 0 plus 1 equal to 1. And that is again going to update back to here sum. Now the new value will be 1. And after that, I plus plus. Now this I plus plus. I was previously 1 and it will become 2. Again it is going to update here 2. So after that, again cancel will get checked. I less than 6. Yes, cancel is true. Again instruction sum equal to sum. Again we have load this data into here. I now 2 and sum now 1. And after that we have to perform here the operation by CPU. 2 plus 1 is 3. Now again it will get back to here 3 and I plus plus it will become 2. We know that we have to fetch again and again the data from this RAM to the CPU registers, and back we have to update that value in the RAM, because actually these are static variable. They have been stored in the main memory RAM. We now have that we can say we have to switch from switching takes place from CPU to RAM and back RAM to CPU. And in this switching process, it consumes some time. The time is going to be wasted, and in turn, the speed, we can say the execution. We can say this speed gets less. Execution speed hampers. There is a hamper, and the efficiency gets reduced. So this switching process, in order to switch from RAM to CPU, back CPU to RAM, it consumes some time. So in that time results into we can say reduces the efficiency of this program. So we can say the efficiency of the program gets reduced due to this switching process, and it takes more time. We can say the processing time increases, and the processing time increases. That means we can say the speed of processing gets slow. So in turn, the efficiency of the program gets reduced. That is the main disadvantage of the program considered so far. Now the question is, so why should we not, instead of this here only, instead of here, if I write the registers, for example, register. Now what will happen? Instead of here only RAM, these variables are going to be stored directly here. Sum I equal to 0, I equal to 1, 0, and sum equal to 0. Instead of storing these variables in RAM, they are going to be stored in the CPU, in the data registers. Now this instruction sum equal to sum plus I in processing. Now it can simply take these data from this data instruction register, can take data from this data register, and now sum equal to sum plus 0 plus 1, 0 plus 1 equal to 1, it will allow 1, again it will I plus plus, it will become now 2, again 2 plus 1, 3, again sum will be updated with 3. No, now there is no need for switching, no need to go to RAM and load the data back to the CPU and back to RAM, update the data back in RAM. No, and now we can say we have removed this switching process, and obviously the time which we have earlier utilized for this switching process have been saved, and now the execution of the process, we can say the efficiency of the program increases, and it takes less time to execute these instructions, and in turn the program takes less time for this execution. This is a main advantage of declaring the storage class as register storage class, the variable as a register storage class, as to associate the variable with the register storage class. So we know that now that the only difference that is between the auto and register storage class is that in case of auto, the variables are located in this RAM, while in case of this register storage class, the variables are going to be stored in registers, and obviously the efficiency of the program increases when we store the variables in registers. And second point that we have to take into consideration is that we cannot register, if we here write register int x, it is not allowed. We cannot use this storage class as global. We cannot variable which have a register, which have associated with a register storage class cannot be a global. That means global declaration of the variables having a register storage class is not allowed. We cannot use that also. We have to take that point also into consideration. So now the question is here, the question is, if we know that the variables which are stored in the CPU have high execution speed, have fast execution speed, why do we not store all the variables in registers? Because we cannot, the answer is simply no, we cannot store all the variables in the register. Why? Because the registers, for example, it is CPU. These are data registers for data register, instruction register. These registers are very small in size, even in KBs. They are in KBs, kilobytes. If we store all the register, all the variables in these registers, then we cannot execute. We can say then it will fall the shortage of the memory. So we cannot store all the variables in these CPU registers. Now we can store those variables in the CPU registers which we have to frequently use it. The frequently used variables, it is better to store those variables in the registers which we want frequently. Those variables should store in registers. That means the storage class of those variables should be register which we are using frequently. For example, counter and loops. Because we are using loop variables. We are using loop variables very frequently. So it is better to associate register storage class with these variables. I hope now you have understood what is the register storage class, what is the difference between the storage and auto storage class, which variables should we have register storage class, and what is the similarity between the auto and we can say register storage class. And inshallah in the next video we are going to discuss one more register class, that is the static register class. One more storage class, that is the static storage class. Till the next video, take care, bye bye.